So this is the advanced section for the Cad Sunday that says using the same model from our intermediate challenge, we should perform a topology optimization study to redesign the component while maintaining its structural integrity. You understand? Increase the applied load by 10 times while maintaining functionality of the components. And participants should submit original mass, optimized mass, perform mass reduction, topology optimization results, and percentage mass reduction. I mean, final redesign card model, design requirements using all this material, 40% reduction. So let's go ahead to do this. So we already have our part, which is this. Now we need to perform another static study, not to perform another study, but in this time it's a topology study. So instead of static, we go to topology and then I click yes. So it's going to create a topology study that looks similar to what we have. So I go to fixture. I'll be the one to tell it, okay, this is where you fix. Now, applied load. I'm applying a force at this point. Now I'm no longer using 9,000. They say 10 times the previous load. So this is 9,000 times, where's our times 10? So 9,000 times 10. So this 9,000, that's you add one, you'll be having 90,000. So you click on it. That's your applied load. Your goal. What is your goal? You need to minimize the mass. Minimize mass by what? 40%. So your mass constraint is to minimize it or reduce mass percentage by 40%. That's what we want. Current mass of parts. Okay, that's all that we want. We can add displacement constraint if we want to. Most times I just leave it as it is. So I click OK. We've added this. Next thing we need to do, manufacturing constraint, to tell it, okay, if you just go ahead, it will topologically optimize everywhere. But most times it's very interesting thing that you should tell it where to reserve. You understand? So for me, where the bolts are very important that you reserve all these parts. So I'm going to select those parts because you should not optimize and leave this part out. It's very important that it reserve this part. So that's why I have to let it know that, oh, you have to optimize. And so I also tell it that, okay, optimize this hole as well. Leave this part. So you can see it has done that. Now I will also tell it, I want you to leave this particular part, this hole, leave it too. Don't go and optimize the hole. You understand? I'm just telling it where to leave in my sketch. You can likewise tell it, okay, leave this part as well. Don't go and chop it out. Don't chop it out. You understand? But this is not actually necessary for me, so I'll just remove this. What mostly I need is this. I need this part and this part. Yes, you may choose to leave this part. It's okay. I just want a topologically optimized. So these are the regions that I want to remain in my design. You can click this hole too. So to optimize and leave those ones. Now what I need to do is to run my mesh. I can go this way to run it. So it will start calculating, meshing meshing this, doing everything possible. So give it some time. It's going to take a whole lot of time to do all this. So So, like I said, to be honest, this is going to take a whole lot of time for this to optimize. So I think, well, I already have an optimized part that I did here. So let's just switch to that part so you see what it looks like. So this is the optimized part. Let me show you the it's going to take a while because it's been long I loaded it. So you can see the topologically optimized part. I really didn't need this part, so I didn't reserve it. I didn't reserve this part, I didn't reserve this part. So the part that I needed reserve was this, and these holes for my boat. So it's topologically optimized the part, remove all the materials that are not needed. So this particular optimization he did can withstand the 90 times 90,000 Newton without failing. So now that I've gotten this, I can now chop out my particular model to get a fully optimized part. So what I did is to work on this, taking into consideration all this. So this is it. This is what the final output looks like. I fully optimized this. Let me remove so that you see it. So this is my part now, fully optimized. So this is fully optimized parts that can withstand the particular loading that I want. So you may have something slightly different, but it will look something like this. So that is it. So let's just go back.